All right, so this would be a quick primer on how to get started with Spark. I'm getting a lot of questions like at work from juniors and also online on how to best get into this and what do you need? Do you need a cluster and all this stuff? I mean, there's lots of information on the topic out there, but I think there's very few like easy examples that actually show how to set up a basic like test project in Spark. Because obviously, if you want to start out on a cluster, this gets really complicated. You need to, I don't know, create your Docker containers or set up some VM and all that. And you don't even, neither do you want nor do you need that. All you actually need is just like some standard Java 8 environment, no other dependencies whatsoever. And I'm going to show you how to work with Spark in this context. So let's get going. Well, our project does definitely need a compiler, right, to get started. So we need the Maven compiler plugin, and like every other user of Maven, obviously you can just copy that from somewhere else, and I will do that. Like, yeah, no trickery here, just doing Java 8. So yeah, this is going to be in Java. And then what we will also need is the dependencies, and we want to play with Spark. So we will get a good old Spark 2 latest version. And since we also want to work in like some local context, let's just start out doing it with a good old JUnit and not run like from, I don't know, command line or whatever. It's just so much more comfortable if you do it from JUnit. Plus you also learn how to write your first unit test for Spark app, which coincidentally is the easiest way to start your Spark journeys. So what we're going to do is we'll want to count the words in a text, like, yeah, millions of people before us. So this counts words in text file. Boo. Like this, whatever. And we will do this via some test. So, yeah, no good design here. We just want some map, string to integer. Yep, normal map from some file. All we want. Also, what you always see is that they have this thing, the Spark context in all those tutorials, and they never quite tell you where to get it from. Sometimes they obviously do, but basically you always get it from like configuring your cluster, like setting the URL on the config and then setting this thing up. And then if you make like an app that actually runs on a cluster, you can just instantiate this locally, and it's never quite clear what's actually going on here for getting the Spark context. And let's see how the easiest way of getting this works out. So we'll just do this all in a test function. Public void counts words, right? Always nice to, and always throws an exception, right? If your test fails, you throw an exception, like the assertion failed, some uncatchable thing, and that's why it breaks. And it's always nice, yeah, to name this like by what actually happens. Counts words, not like test counts, because what the hell? We want to know what actually should happen. So, anywho, if you want your local Spark context, what you need is Spark context. Let's see, say new Spark context. This would be the most trivial approach. Oh, doesn't work like I don't know. Okay, just to be able to compile, right? Let's just do an empty hash map. string integer and return it. Yep, make a new one. And yeah, this can be inferred. Nice. So if you just want to run it, I mean, in theory, this should give you Spark context. I'll just start it, just so you see what's going to happen here. And then it fails and says, oh, you know, master URL, you don't have a cluster. Oh no, I need some cluster to test this. No, you don't, and also you shouldn't in your tests. Easy solution is just to, either way, you would have to configure this. So you make your Spark config. This will then just be fed in here. Obviously, this way it doesn't have a master URL. But you need to set. You also need to set your app name. We'll just call it like according to our test. Always a good idea to not have duplicates in here. And then master URL. And the trick here is just to set it to local. This will make it actually start Spark on your local, give you a local node. And then you can see, woohoo, it works out. But yeah, this doesn't suffice, obviously, because we want to actually count words. So in order to be able to do that, what we first and foremost need is words. So let's write words to a file so we can use it, right? So an easy way to do this is basically to just say, okay, we want our new file. So we create a rule. Right, if in tests, if you want to work on files, nice to do that. Yeah. So JUnit has a very nice way of handling it with a rule and a new temporary folder. And in said temporary folder, you can then just create a new file. And then you can call it input, right? We use this as the input. And then if you want to write to a file, I always like this one, right? If you don't have any like tricky thing, just do toPath and then you can take any string and then get the bytes from it. And then like, I don't know, foo bar. And let's make it multi-line, bar, foo. And, I don't know, foo, bar, whatever. Right now we should, when we actually count the words in here, get, it's early, so it's 5 bars and 4 foos. This should be it. So if we do like counts for Spark context, right, and the input file get absolute path, this should be our final results. String integer. Then in theory, if we were to like go through the pain of handcrest, assert that results get true, should be matches, and gotta be careful here to use our handcrest ones. I think it's core matches, yeah. If you don't include the actual handcrest matches, it's weird somehow. Anyways, so this should be would be the correct result if this actually ran through Spark, which will not have, will just be 0, null, whatever here, right? Yeah, because obviously we didn't do any Spark yet. So instead of doing this, we need to use Spark. Spark always operates on these resilient distributed data sets. It's basically like its unit of data. And that's what we need. We need a Java RDD, and it works on a string. And we will read that from our file. So what we use is our Spark context, and then like they show you in all the short. We say, okay, read the text file. So we read from our file, and we say we have to give the minimum partitions, like how many like parts do we want to split this file into at the very least. We can tell it that, and we do 1 because our file is like really small. It only has 3 lines. Also, what it then tells you is this doesn't work because Spark is written in Scala, so we have to convert this to Java RDD type. Otherwise, it gets kind of awkward to work with the Scala types in Java. Alrighty, now what this would contain is just string, no counts, and what this in fact is it's just all the lines in your file in a set. Like, it always splits by lines. That's how Spark operates. And eventually we do want a map, right? String to its count. So what we have to do is somehow get this into a map. But for now we basically just have a set that has the lines in it separately. You can try it out if you want. You could just do like RDD, like for each, say, new function. No, just so you can see it, and then just do like system out print line s, right? It here, like basically just prints them all out, right? Even with the spaces we added here. If you look, I have spaces at the beginnings of the lines, and then puts like each piece of this set into one line here. So this is not what we want. We obviously want to have all the words separately. So step 1 in achieving that would be to map this set of lines. You can actually call it appropriately, just name this the lines, to words. So lines need to be mapped to words. And what we're going to do is flat map. We want to map from the type we already have to the same type, and not like create anything like nested or anything. We just want a flat set of words now, of strings again. So we do this, and then what we need for that is use a function, which in this case would be a flat map function. And it goes from string to, again, string. Yeah. Thanks, idea. Just type in enter and it works. And then it says, okay, you need to have an iterator here. Because Spark will then internally go over that iterator and put everything back into new RDD. So final Java RDD string would be the return type here for words. And what we can just do is like low tech. Our example is easy, right? We split. Okay, we get an array, and then we can do like arrays as list, turn the array into a list, and then get the iterator for it. So now we have words. We can just choose like 2 words for each loop over this. I'm not like turning this into lambdas or anything, just for readability, just so you see what you actually need to have here. So if we go like run our test again, then incidentally just calls this. All the words. Already looks a lot better, right? But we still need to count those. And the way we do this now is that we basically need to turn them into pairs, right? Every word needs a count. So what we would do is we would say, okay, we want to map this to pairs. So words map to pair. function. And what the function would do is it would take like a string, and then the last two are the key and the value of the pair, and it would map it to a string. A string here mapped to an integer, or string, like being able to look up an integer, like a tuple, right? Two things. And we want to match every string to a pair with its count. And note, right now we have duplicates here, so each string is there once, like in this set of words, because we have duplicates, like it's just these straight strings. So all we would just do is say tuple from a string and a 1. And then we would get a final Java pair RDD of string and integer. And we could just call this like ones, right? Because, well, it's always like a 1. Could, if we so choose, again do this, like take our ones. Yeah, this is not so much fun. Suppose like do like tuple to string and integer. You can check what it prints this at. I'm not. I don't know how nicely serializable this is. I think it should be like human readable. What is produced here? Yeah, like so. Now we have all of these. So basically, like it's always like these steps and these jobs that could run on a build machine. So if you want to build 1,000 more, that like step by step turn what you have into what you want in terms of like transformations on sets and maps. So we turn this into this, and then into this. Like in Hadoop, we would call this like the map phase, where we basically map our data to the structures we want to work with. So once we got this done, we want to count. So what we do here is we say, okay, yeah, you already know it, like we get a Java pair RDD string to integer counts. And we somehow get this from the ones. And the way we get this is reduce. So that's why in Hadoop we say map reduce, right? First you get your data into this paired form, and then you reduce it. And let's reduce it. It's kind of funny. No, basically reduce by having an integer that, yeah, we want for every like set of similar keys as the output. And it's produced from like pairs of integers. So we always produce an integer. We have like our value 1 and our value 2 that we want to somehow aggregate to a final result. And yeah, in our case it's really easy, right? If you what you want to do is with your values, you want to add them all up per key, per word. So you would get your counts. Just reuse our ones, and then run the for each over those, over the counts, and see if this now makes sense. Excuse me. And yeah, it makes sense, right? We had 5 bar, 4 views. And then if you wanted, you could also take your counts and turn them into a map, like for further use in your Word or for your testing here. Now we can run our test. And it works. It counted the words, and you could run this on like a bunch of machines if you wanted to, and would still work out nicely. And basically, like, well, running this on a cluster, the only difference really would be in setting a different URL here for the master. And Spark would do the rest. And that's it. No cluster needed to test this. No complication whatsoever. Just like straight programming. Could even like just for the heck of it, like, simplify this a little. Just so you see what you would want to go for. Like you wouldn't want to do the printing, obviously. And then yeah, idea is probably right. You want it easy. You want lambdas here. And also all these variables are actually kind of redundant. Right here, who needs words? Like no need to even have this. Lines is fairly redundant too, right? We are using just one, so ditch this. And then this whole thing here is basically fairly redundant. So we could just also not have this variable. This, and then we wouldn't even need this because let's put this in here, and it's just one giant like chain of mappings. Right. Do this, do this, do this. This. Basically, it's really easy, right? We take the text file, make it Java callable, basically just a cosmetic thing. In Scala, we map strings to words, lines to words. Yeah, have to do the iterator, it's just the interface. Map them to pairs. So we have the one here. Reduce the whole thing. Add together for equal words, equal keys. And return the map. And run it again. Works out just fine. Now also without the weird stuff. A weird prints. It also gives us the Spark Web UI. This will not work. But yeah, that's it. Thanks for watching.